case studies, some of the use cases we'll discuss today as well. So if I say data science is nothing but it's a combination of statistics, mathematics, computer science, and domain expertise. So why domain expertise? Because data is coming from various domains. So data is like has to be analyzed. So mathematics is important, and computer science is another importance here because we have to program, we have to develop the algorithms, we have to make the application, business logic implementation. So it's combination of both like mathematics, statistics, computer science, and different domain expertise, right? So there are key components if we talk about data science. So very first is the data collection, because if we have to analyze or implement any application, so first and foremost is data collection. So I need different set of datas, right, which I require to analyze. The second key component is data cleaning, because you are getting data. You don't know what is the kind of maybe noise is there, or maybe data is not meaningful. So data cleaning is another important aspect. So as much as clean data you have, you will get good results, good analytics outcomes and all. Third is like exploratory analysis, because sometime we don't know data, what sort of data is that. We have to explore. So we have to analyze, we have to find the different patterns out of the data, different characteristics of the data. So that analysis is also very important. Then modeling and machine learning. So based on the data type, we have to model the, like create the models, and we have to write the machine learning algorithms and all. Right. And last is the communication. How to communicate this data to the world, to different modules, different ecosystem applications. So that is, so these are the five key component when we talk about data science. Okay. So like the next we discussed, like data cleaning is very important. So data cleaning is like noise removal, normalization, then splitting the data into the different categories, then mapping the data, tokens, right? Then next stage is like exploration, data analysis, like analyzing the data. What sort of data is this? Then based on the data patterns, based on the data type we collected, so we have to select the models. Then based on the model, we have to do the predictive modeling, machine learning modeling, where again to prove the models, we need again data. One is like test data, one is training data. So when we train the data for the machine learning, we always have two set of data. One is like training data, another is a testing data. So training data is like big chunk of the data. If you don't have testing data, so generally what industry do, so whatever data we have collected, suppose we have collected say 1,000 points. So 700 points I will be using for training the model, and 300 points I will be using the testing. So like I split the data into two parts. So major chunk for training and major chunk, then small chunk for testing. So this is how the data science workflow works. Okay. So next stage, if I see, so there are four different type of data analytics happens mainly in the industry. One is like descriptive analytics. What is descriptive analysis? Where the question comes in mind, what happened, means summarizing the past data. For example, monthly sales, right? Past month, maybe sales, then followers, then visitors. So all these kind of what happened question is answered. That type of analytics called descriptive analysis. Second type of analysis is diagnostic analysis, where the question comes, why did it happen? Like we are trying to find out a root cause. So it explains based on the past events, based on the past data you have, what sort of issue, why the issue happens, right? Root cause analysis. So that kind of analysis is called diagnostic analysis. Third is like predictive. So where you have to like what will happen next, where the question is answered like what will happen next. For example, like you are running like for example in our case, so we are running a EV charging ecosystem and network, right? So for our customers, it is very important to understand how much energy they will require in the next month. What will be energy consumption? How much revenue they will be getting, right? So for banking sector, like how many customer maybe go for loan default category. So these kind of analysis is called predictive analysis. Then another is prescriptive analysis, where the question is answered, what are the action should we take? Like we have analyzed, we have summarized the data, we found the root cause, we predicted the things. Now what are the action we need to take based on the uh, prediction done by the data. For example, in electric vehicles, I'm giving a very example. So we are having vehicles which are running as a fleet, okay, in the field. So it is a battery operated vehicle. So we have a limited energy in the battery. So it is very important to for the fleet companies or the companies who are running the delivery business, like how much energy they have and what is the optimized route for them, so that they can do more and more deliveries with the available energy in the battery. So this is like how like prescriptive analytics comes into picture. Okay, so as we are going from descriptive analysis to prescriptive, the complexity is also increasing here. So because we are again doing further deep dig, further analysis, further modeling, so complexity will be increasing. And as we are going to prescriptive analytics, the value is also increasing. So it is more meaningful if I tell, okay, what I you can optimize the route. Okay, I can forecast something, I can predict something. So I am creating more and more values. Okay, so if we take a like, I want to give you an idea like what time series analytics you must have read in the book. So any kind of analysis which is done in time ordered data point on a regular interval. So time series analysis, like if you see in this graph, so we have the data points, right? So we also have a timeline. Okay, year, it may be year, it may be months, it may be minutes, second, hours. So whatever data we are able to analyze based on like in time ordered data points and on a regular interval. So that is called as time series analysis. So there are certain key features which we are doing, what it can do. So it helps us in capturing the trends. It helps us in capturing the cycle, seasonality, right? Seasonality or irregularities. So seasonality means like you must have seen, like take example of a Big Bazaar or maybe Reliance Mart. So their sales trends during the festive season, say every year Diwali, they are getting higher sales. At Holi, they are getting higher sales. So this is like seasonal. So which is happening, repeating the things. So those kind of analytics or features are called seasonality, right? So we'll see different algorithms in coming time where in the next slide. So what are the different models and algorithms which are used in time series analytics in the industry wide? Okay, then why time series analysis is important? So first thing, as I mentioned, like forecasting, predicting the future demand, pricing, patient health trend. So now you can correlate based on the examples, like what are the different application industries where time series analysis is used. Like future demand means energy sector, prices means again energy sector, patient healthcare, right? Finance sector, then anomaly detection. So if you have data which is within the limit is going on timely manner, so it means everything is normal. So take an example of like fraud failure. So if suddenly we are seeing, okay, outliers are coming between, it means some anomalies there in the data, like with the help of graphs. So graph visual implementation, visual representation also helps in helps a lot to the industry people to find out very quickly what is happening, something fishy in the data, right? Then third is like decision support. So as I mentioned earlier, right? So sometime based on the data, we have to take decision. For example, in share market, people see the past trend, how the stock is working. So based on that, they take a decision, okay, I should invest or not. A similar way, decision support in manufacturing industry, if I'm seeing my all data is within the limit, so it means my machines are running properly. If I'm seeing, okay, some inputs or data coming which is outliers, I can take a decision, okay, my machine may break down. Okay. So it helps in a lot of time decision making. Then optimization. So if I have data, I have a trends with me. I can all. It is really helpful for us to optimize the resources. Resources means based on the data, I can say, okay, I have lot of traffic, I have lot of rush, I have lot of customers. I need to have like maybe increase the salesman. If I am seeing, okay, in one of the store in the retail chain, they are saying, okay, the footfall is not that good, so maybe one person is good enough for me at that particular store who sell the products. So this is like how data is helping, how time series analytics is helping in optimizing the resources or allocating, planning, operational planning, many things, right? So if I tell, like, there are different steps in time series analysis. So very first is like visualizing data. As I mentioned in the previous slide, right? So visualization is also very important factor. Based on the trend graphs, I can easily identify, okay, everything is normal or something abnormal in the data, right? Then decompose the series, like separating the trends, seasonality. I mentioned seasonality. So if I'm analyzing the data of a retail chain, for example, for Big Bazaar, so I will see the peaks during the Diwali time, peaks during the New Year, right? Because those are festive seasons. So I have to decompose the data series based on, okay, this data is seasonal data, so I have to plot a different seasonal trend. I have to maybe remove the noise component out of the data. I have to separate out the different trends. So that's the second step, decompose. The third step is test stationarity. So how statistical property remains constant over time. Like my data is constantly coming in a similar fashion or different, right? So that also I have to analyze. Then analyzing the autocorrelation. So detect the temporal dependencies between the observation. So it may be like temporary dependencies or maybe some observation, right? So I have to maybe correlate the data, analyze that also. Then model selection is another step. The next step is like model selection, where it may be ARIMA, maybe auto regression integrator, right? So or maybe exponential smoothing. We'll discuss this models later, right? And then evaluating the model. Maybe I have to have different MAP metrics, right? RMSE metrics, different metrics are there. So then forecasting, so predict future values with the best model. So it's not like that I chosen the model, I worked out that will really fit with the analysis which I am doing. So lots of time we have to experiment with different models. So based on the data type, based on the data behavior, we have to select a different type of models and fine tune them. Right. So AR model I already mentioned, like auto regressive model where predicts the current value from the past value. So where I have to do a prediction. So AR model is the most used. Secondly is moving average. So moving average is like it take a average of the past data also, past forecast error to smooth out the data. So it's like first in first out. So when we are doing a moving average, for example, I have a 10 samples. So I will discard the first sample, the new sample I will cover in that. So it will help us to smoothen out the errors, right? So based on the moving average data. Then another is ARIMA and SARIMA. ARIMA is nothing but a combination of moving average as well as auto regression model. It's a combination of both. So it handle both data in a better way, where I can predict also, where I can fix the error also. So then another is SARIMA. SARIMA is like if I add a seasonal thing where I can put one more filter where I am taking care of the seasonal trends, which I mentioned, like in the case of festive season data, right? Exponential smoothing, where I take a observation and weightage of the different data sets. So based on the weightage of the data points, right? Then Prophet is another model for by the Meta. So it handles non-stationary and seasonal effectively. So where you don't have any stationary data, very dynamic data type you have different type of seasonal data, different patterns of data. So in that case, Prophet is one of the widely used model. Okay, so if I compare between all these models, comparison if I do, so comparison like auto-regressive model. So in one liner, if I explain, it predicts the values future based on the linear combination of past observation, right? Past data sets we have. Then simple, very simple. As I mentioned, it's widely used only for the prediction purpose. Then stationary data, autocorrelation. Then it works with time series with autocorrelation mode. like where it automatically correlate and create the relationship between the data, past data points. The use case is like energy consumption prediction, the share stock predictions, pricing predictions, and all. So moving average, like it's again like smoothing the error based on the average of the previous data points. So it keep on considering the previous data points as well as the new, mix both and forecast the error. So it's again like helps or helping us in like short-term fluctuation, noise reduction. So it again help on stationary data with the noises. So mainly moving average in terms of embedded system also we use a lot of time to smoothening out the errors coming from the sensor data. Right? IoT, in case of IoT, moving average is widely used. Right, ARIMA is like combination of AR and MA both. It's flexible, which is having properties and capabilities of autoregressive and moving average. And then ARIMA is again like if I take all three models plus seasonability if I add to it. So seasonal data, non-stationary data, so it works well over there. Exponential where I take a weightage of different data points and it helps in like seasoning and trends data analysis, seasonal data analysis, right? So profit I mentioned like it's robust to missing data, shift in trends, where I have abnormal data, or where it works. Okay. So there are certain best practices we follow in the industry. So very important for us is like data quality and consistency. If you are doing any data science project, so it is very important for you to build a data source which is having a good quality data and you are getting a data on a regular interval because it's time series data. So any interval missing data will mislead you. The second is like exploratory data analysis, like where I mentioned like, so we plot different visualized trend, decompose the data, we have to analyze, okay, what sort of data it is, what kind of models I can do, what kind of analysis I can do. So you have to decompose data. Then third best practices we follow is like model selection and validation. As I mentioned, so you can always not rely on one model. So model selection is always done based on the data type, validating the results, and then back testing. So it may be today one model you have trained, it is working fine. Tomorrow some new type of data you started getting. So maybe you have to fine tune the model you have existing with you, or you have to maybe try the new model to get the better results. Right. So these are again like we always not rely on one model. So we always keep on experimenting with different models. We do testing, analyzing, and validating them. Then continuous improvement. It's again like always as I mentioned, like tomorrow maybe you get a different type of data. So any change, any drift in the data will hamper the results. So always you have to have a feedback loop in your system, what you design, so that you get improved data model, right? So you get better results and it accommodates the new type of data. So these are the four different best practices which we follow in the industry when we do any of the data analysis. So I'll give you example like industry like finance. So finance I already mentioned like stock price forecasting. So here ARIMA or deep learning models, LSTM. So which is followed, right? JP Morgan. If you see, it's a market analysis company. So they do a lot of reports, analysis reports, and forecasting based on the data. So they also use the time series data analysis. So risk management. So if I say how volatile my model is, GARCH for investment stability. So special deep learning algorithm, generalized autoregressive conditional model is there, right? Healthcare, if we see like patient monitoring. So you must have seen ECG, EEG, EKG, right? These are again time series data only. So based on that, doctor predict, okay, how health is going on, right? Remote monitoring. So wearable, if you see most of us having Apple Watch, Samsung Watch, right? So if you anytime track your sleep or heartbeat, if you open the mobile application, you must be seeing this time series plots only, how you are doing in a time, different time interval a day, right? So then clinical trials. So a lot of data we are getting over the time from various test reports, trials of medicines. So based on that also a lot of monitoring happens. Then if we take example of manufacturing industry, so that is also widely used here. So as I mentioned, like predictive maintenance. So if I'm getting a lot of data sensor installed in the machine or the equipment, right? So based on the sensor data, I can forecast, okay, my machine will be going to break down maybe in another 1 month or maybe 6 months down the line. So which helps to increase the efficiency of the production. Then process optimization, right? Where I can monitor the different production line efficiency based on the trend. I can optimize, okay, my efficiency is going to down. I have to put more resources, or maybe efficiency is very high. So I can reduce the resources, right? Quality control. So a lot of data based on the anomaly, data trends, we can say quality is not good. So maybe some parameters which are coming out of the limits. Then retail application, if I say sales forecasting, as I mentioned, right? So retail stores, they do a lot of forecasting, like what is the demand they are having, how much inventory they want to manage. So based on the sales, they can predict the demand and the inventory stock, right? Then customer behavior. So as I mentioned in the last slides, like based on the footfall of the customer, based on the sales pattern, I can analyze, okay, this store is very busy store. Then dynamic pricing, I can adjust the pricing. You must have seen in the Ola, Uber, right, where based on the real time, they also do search pricing. They increase the tariff of the car booking. So based on the demand, if supply is less, always prices are higher. So that prediction, dynamic pricing, is done based on the time series analysis. Then telecommunication. So we are seeing millions of mobile SIMs, right? Everybody is having two to sim, three SIM cards. So have you ever observed, okay, everybody is having Instagram utilization, LinkedIn utilization, how much traffic is there on the, so how much traffic is there on the network? So predicting the peak load. So based on the previous trends, like, okay, maybe yesterday between 10 to 5, there was a peak load. So we do in EV also. In our system, we predict, okay, between 4 to 5 is the most busy time on the charging station. So we also do analyze this. Then infrastructure planning. So based on the load in any particular area, companies install mobile phone towers, cell phone towers. Earlier they used to have at a fixed places. Now dense area, they are having more than one towers. So this is again done based on the time series analysis. Then fraud detection. So we are seeing a lot of calling pattern. So Airtel recently launched a AI-enabled fraud detection thing. So like Truecaller, Airtel team is automatically detecting, okay, this is a fraud. Okay, this is a spam call. They are also working on this similar kind of analysis. If I take example of transportation, we are seeing a lot of airplanes are going, shipping industry, trucks are moving, logistic industry, right? So route optimization is done based on the analysis, right? Then predictive maintenance, then demand forecasting. So now you can see how useful this time series analysis in the industry. So another applications like entertainment and media. So you must have seen Netflix. They also keep you suggesting based on your behavior. Then smart cities like IoT, energy use, traffic monitoring, public safety data, then hospitality and tourism, so hotel booking. So you must have also seen nowadays airline, I don't like, if you open make my trip, so if you search say Delhi to Bangalore flight multiple times in a day, so or maybe within 15 minutes you will see that they will keep on increasing the price. So it is again noticing your trend, how fast, how desperate you are, how much traffic they are getting for this flight. So based on that, they are also increasing the price nowadays. What Arima last 5 years historical data pattern, the risk reduction by 20%. So improve the trading strategy. So a lot of nowadays trading apps, they are coming up. Okay, we are a AI enabled platform where we'll help you predict of like select the best stocks. So this is based on the data only. Right? Predictive maintenance. So unexpected breakdown. The approach is like different data sensors. Data is coming. So time series modeling done on that. It helps reduction in downtime, machine breakdown by 30 to 40%. It depends on industry to industry. Overstocking, stock out. So based on the holiday season, based on the demand, they can, as I mentioned in the earlier slide. So it's again like Arima on the algorithm on the last 5 year trend data, sales data. It's increased the sale by 15%. If you have stock with you, definitely you will sell more. If you don't have stock, products available in the store, and customers are going back, so you are losing the customer, you are reducing your sales, right? And even though if you have a prediction, so you can reduce the waste also. Sometime you have a perishable goods, so you can stock less if you are seeing there is no demand of that particular product. Why to base the product? So EV charging, like as I mentioned, like EV charging is like working on the different trends, how much traffic I am getting, how much energy I need. So lot of energy companies, they are doing prediction based on the demand on a particular area. So they make sure that okay, we can manage the supply in that particular area, or maybe we can mix both renewable energy also in that, so that we can balance out the demand, right? I can optimize that. Profit model is used because here data is not fixed. Two-wheeler vehicle is less demand of energy, four-wheeler vehicle came, or maybe bus came. So weather data, weather condition, lot of other conditions are coming into picture. Waiting time can be reduced by 25% if I do a balanced energy procurement, if I optimize the energy utilization. So it's again beneficial for us. If I tell you, like if you have to learn, or maybe you have to work on time series analysis. So Python is more widely used. Another is the R platform, but Python is open source. R is again paid license, but Python is having a lot of libraries like pandas, stats models, scikit-learn, right? Prophet, Keras, TensorFlow. So these are the different libraries you can use for your time series analysis. Then if you are working in a cloud platform, so Google Cloud AI platform they have, AWS they have a forecast, Azure also have time series insights as a module, as a feature set. You can use that. So then visualization is another important part. To plot the graph, Power BI, it's again a paid license. Tableau is again a paid license, but Grafana is an open source platform. It's Apache Grafana, so where you can use this platform to plot the graphs, to plot the time series analysis. You can plot there. Then different type of databases like ML Flow. If you are working on machine learning, Apache Airflow, then InfluxDB, MongoDB, Timescale, because these are time series, so mostly non-SQL databases are used here. Like as we learned, there are benefits, but there are challenges also. Missing and irregular data. So as I mentioned, like data regularity, data quality is very important. So if you have a missing data of maybe 1 month from last 3 months, so it means you cannot analyze properly, right? You are having a lot of data missing there. Maybe you are having a partial data. Okay, 1 month you have a data, next month we have only 15 days data, then next month complete data, next month 5 days data. So it's an irregular interval. So this will also hamper your analysis, like non-stationarity data, then model drift and latency, because it's also important because how fast and optimize your model which you have chosen, how much error that model is generating, how much delay that is creating. So choosing a model is also very important. That's why I'm asking, like you have to experiment with different models which can help you in a better optimized way, better results, faster results. So future trends, if we talk about, so integration with reinforcement learning is another future trend. Edge computing. So you cannot stream all the data on the cloud every time, because it's again maybe network latency may come. People are coming with a solution. Companies are coming with a solution where a lot of data they are gathering in the factory floor on a small edge device. They analyze there and send only the meaningful data, clean the data on the edge, which is again a cost optimized one, because cloud resources are again costly. Streaming the full data to cloud is again a cost, right? Data cost. So edge computing is another trend which we are seeing growing very fast. Explainable AI for forecasting. It's again like AI model, Gen AI models are also people are integrating, where based on data it is also helping on top of machine learning models, right? Then automated time series, auto ML, a lot of tools, libraries which are coming, which are used to automate the time series data analysis. Then if you see, it's very vital for smart decision, smart industry, various across the industries, I would say. If you want to learn, so there's few books I have mentioned here by Ellen Nielsen. So there's a book, Practical Time Series Analysis. This is very good book. And another is Forecasting Principle and Practice by Hinman. So this book is available free online. Then courses, if you want to do, so Coursera, there is one course, Practical Time Series Analysis, and on Udemy there is Time Series Analysis and Forecasting. Then website Kaggle Time Series Dataset, where you can get lot of data sets for your analysis readily available. maybe sales data, forecast data, many data set you can get download from there. Then towards data science time series, so these are two websites which I recommend. Thank you. This is all I want to share. And if anybody want to connect with me, so scan the QR code. I am available on LinkedIn as well. Yeah.